I'm Abro, and today we're going to be presenting how to clean up messy notebooks in LineaPy. So to start out, I have a question for you guys. How many of you guys have dealt with having to clean up terrible code? You know, something like this is obviously a very humorous example, but I'm sure in real life, a lot of you guys have to spend hours and hours doing this. A quick agenda for today. We're going to, first of all, give an overview of what exactly LineaPy is. Then I will be passing this off to my colleague Ion, who will be demoing exactly this situation with the Jupyter notebook. Then we'll have some Q&A and then some next steps afterwards. Okay, so a quick overview. What exactly is LineaPy? So the central component of LineaPy is the artifact, which is a combination of code and a value. So if you have some data that you're manipulating, then basically you can save the end result of that in an artifact, and then it'll capture exactly what code went into calculating that value, as well as the value itself. And the cool thing about these artifacts is that they're saved in a database, so they can be reused and then automatically be converted into pipelines with pipeline orchestration software such as Airflow. LineaPy basically works on any platform that runs Python, so you can run it on a script, you can run it in VS Code, Jupyter notebooks, Colab notebooks, or Databricks notebooks, so pretty much anywhere. The magic begins when you type import LineaPy. When you do that, then in the background, LineaPy will start processing every single line of code and convert it into a graph. Then when you call lineapy.save, then LineaPy basically takes a chunk out of that graph and calculates what exactly was the nodes leading up to the node that you're trying to save, and save that as an artifact. So this works basically on any sort of data, right? So it can be a model, it can be just an integer, it can be a data frame, it can really be anything. And then the toPipeline function is used to convert it to some sort of pipeline that can be used with Airflow or Spark or Dask, etc. So some of the amazing people behind this effort are co-founders Doris and Yifan. They both have PhDs from Berkeley, and then they founded this company. We have Shardul, Mustafa, Sangyun, Mingjer, Ayan, who will be presenting the demo later today, and myself. Okay, so now we've gotten to the demo. Feel free to click on this link or scan this QR code on this page if you want to follow along. Okay, I'm going to be passing this off to my colleague Ion to demonstrate cleaning up messy notebooks. Take it away, Ion.
Also, if anyone has questions, feel free to interrupt or send messages, whatever is most comfortable for you. And we have Sanu and Mincher here to help answer them.
Thank you, Abro. Let's get down to the demo. In case you are working on the notebook right now, you can start by running the first few cells, which are just going to perform some setup. Just note that if you see a message saying that your session crashed for an unknown reason, that is okay, because we need to update the IPython version in Google Colab. And you can just run the subsequent cells after seeing this message. So I've already run the first few cells. Let's come to the scenario. Imagine that there is a data scientist performing some exploration on a data set. The data scientist may want to add some columns, add rows, delete rows, sample some of them, and join it, append it to the original one, join two tables. The list is endless. And during the exploration, performing these operations in no particular order leads to nonlinear workflows. And for such a nonlinear workflow, we have examples of really good frameworks like Colab, Jupyter notebooks. However, there are some issues which come up when we have to deal with nonlinear workflows. So, suppose that after working on our data set, we want to share our findings to a colleague. We could share them the entire notebook, or we could share the generated data frame which we have to our colleague. However, the issue with this is because of the nonlinear workflows, we might have executed the cells in any arbitrary order. We might have executed one cell multiple times, or some cells we might not have executed at all. And due to that, one person who might want to reproduce our results may have a lot of issues with it. Just by having the node access to the notebook, the second person might not be able to reproduce our results. Then another issue could arise when we have not worked on the notebook for a long time ourselves, and we ourselves forget how we created the results. And the same issue arises that we ourselves might not be able to reproduce the results. And another issue is that we might want to productionize our workflow. We might want to hand over the notebook to an ML engineers who would convert the notebook into a pipeline. But again, if they do not know the exact order in which through which we generated our final data frame, they won't be able to reproduce our final value, which is what the data scientists intended, and this leads to a major bottleneck in when it comes to data science. So there are one might think of some ways to handle these issues. We can perform version control on the notebooks, which can be an additional overhead, and it is cumbersome, and people can have issues using version control software. How, Also, another way is that we could keep the notebook in a sequential state, in that we could execute the notebook from the top, from the first instruction to the last instruction, or all the times through our exploration. But in that process, even though we are able to linearize the notebook, it actually defeats the purpose of having nonlinear workflows, which is extremely useful for data exploration. So yeah, so what can we do here? So fortunately, LineaPy has a great solution for this. With just 2 lines of code, LineaPy will help you remove the complexity from the notebook. It can help perform code cleanup. It can perform automatic versioning, and also can generate pipelines. So in today's demo, we are going to take the example of the iris dataset, which is provided by the scikit-learn library, and we're going to perform some operations on the data frame to mimic some common data science workflow pipelines. So let's get down to it. Yeah, so in the first cell, I've just downloaded the data set and stored it into a data frame. And we can just explore the data frame of the iris data set. We can see that there are 4 columns: sepal length, sepal width, petal width, and there are 150 rows. So now what we want to do is we are going to save an artifact corresponding to the original data frame when we have done no operations on it. Right. Now what we are going to do is we are going to perform some mutations on the data. So first, I'll instantiate some variables which correspond to 3 different mutations. So we have the first mutation, this one, which takes in the existing columns of the data frame and processes the data and creates some new columns. The second set of mutations is just going to sample the existing data frame and concatenate it with the new one. And the third mutation is again going to perform some sampling and also will do some scaling of the values of the data frame. So these are the 3 mutations here. I can let's say I can run them once. Let's say run them this one. I run mutation 1, mutation 2, mutation 3 one time. And I also perform some plotting, and after a basic set of operations, let me say that I have saved an artifact. And here I can see I performed all mutations once. Now I want to perform some more mutations on the data. So let's say I perform mutation one more time, and then I perform mutation 2, and then I again perform mutation 2 multiple times. And then let's say I perform mutation 3. And I can see that the plot has changed. But let's say I'm not satisfied with the final range of the data. I want it to be around less than 400. So let's say I perform the scaling multiple times, and I see now the highest value is not is less than 400. So I'm happy with this data set. So with the final data frame, what I'm going to do is use the LineaPy save API and just save it. And we have logged that we have run the type 1 mutation twice, type 2 mutation 4 times, and type 3 mutation 5 times. Now, so we have saved our artifacts. Now what we want to do is let's say we want to share this artifact with our colleagues. So for that, LineaPy provides an API called getCode, which is going to output the code which is used to generate the artifact. And we can run this API. And here we notice a really cool feature of the getCode API is that it automatically cleans up the code. So that means that only those instructions which are relevant to creating the API in its current state are going to be included, and all the instructions which are not important for this data frame will get excluded. So you can see there are no comments and no statements which did not go into creating this data frame. And one more thing which we can notice here is that when we ran the mutation, let's say we ran the mutation number 3 5 times, we can actually see that the instructions corresponding to mutation 3, which was a scaling operation, this one, and this one, it's actually included 5 times. And we can see that also we are able to actually see in which order all of the 3 mutations were called. So the getCode API is able to simplify the task of cleaning up your code and seeing how your final data frame was created. So in case there are any questions, please you can ask me or write it on the chat. Yeah. So for now, I'll continue on. So LineaPy also provides another API called getSessionCode, which can be used to validate the correctness of the cleaned up code. So getSessionCode is actually going to print all of the lines which were used to generate which were executed while generating the current artifact. So this will also include the comments and other variables like the variables C1, C2, C3, which we had used for counting. So all of the lines will be executed here. And yeah, so after this, let's move on to another cool feature of LineaPy, which is the artifact store. So what can happen is that it is possible that during our data exploration, we might end up doing operations which we later realize were not necessary for our use case, and we want to kind of revert back. So when we use the LineaPy save API, it actually does not override the previously saved APIs, and it actually all of the saved versions get stored in the variable called in the API called artifact store. So if I run this command, we can see that the fancy iris artifact was actually saved 3 times, and hence we can see 3 different versions along with the timestamps. And another thing which LineaPy offers is that for each of the previous versions of the artifacts, we can also evaluate the code. So if we so for example here, for the first version of the artifact, when we had not performed any operations, if we just run the getCode API, we can see that it only covers the code for importing the relevant libraries and loading the data frame. Whereas if we try to find out the code for the last version of the API, the latest one, we can see that it would include all of the lines which were used in generating the final version of the API. So this is a really cool feature um, which helps us automatically perform some a kind of version control on our data science without the need for any other version control software. So we can see from LineaPy that all of the complexity of notebook cleaning has been removed here. And whenever we want to further refactor the code or modularize this code, we don't need to start from scratch. We can use the existing artifacts which have been saved. So just a quick recap. This demo has shown that how LineaPy can help data scientists, data engineers, and ML engineers save precious time on manual notebook cleanup, which is often a major bottleneck in data science workflows. And by saving time on these cumbersome tasks, data scientists can focus on more valuable activities such as generating useful insights from the data. So thank you for the demo. I'll let Obro have it back.
All right, thank you so much, Ion. That was an excellent demo. Okay, so a couple of takeaways, I guess. So this is our entire API, essentially. As you can see, it's not that many functions. It's pretty easy to learn, and it's designed that way pretty purposefully, so that our LineaPy is really not that difficult to integrate into your workflow. So there's the save function for actually saving an artifact, artifact.get code for getting the code of an artifact, get session code was getting the complete code of a session, and then the artifact store, which gets all the artifacts, and then get, which gets a specific artifact. Okay, now we're in our Q&A portion. So if anyone has any questions, feel free to ask them now. This can be about the demo or about our product in general, or really about a lot of things.
Yeah, I see one question in the chat from Xinyue, and I can read the question. It looks really cool. What happens if I delete one cell I have executed from the notebook? If I delete one cell I have executed from the notebook. So what happens is, as Obro explained at the beginning, from the point that you import the LineaPy, the LineaPy system actually traces everything that you execute. So meaning that even if you actually delete one cell, as long as that cell was executed in the first place, it has already been recorded into the system. So what happens is that even if you lost that cell, you can actually when you actually print the artifact, the code, when you execute .get code as Ian presented, that block, executed block, is going to be part of the recording, part of the cleaned up code, as long as that code actually is relevant to the artifact we are talking about. And as Ian said, showed, when you actually execute get session code, which gives you the entire executed session, then you will see that's retained in there. So the short answer in sum is that as long as you execute it, it's in the system. And
right.
For the next question, I can let Ninja take it.
Yeah. So the next question we see is from Josh, and he is asking, does LineaPy help to manage the dependency needed to run my pipeline? So the answer is yes. When you do the to pipeline, run a LineaPy to pipeline to create your pipeline, and meanwhile, LineaPy is not only save the pipeline definition file as a Python file, it also save the dependency, the requirement of the Python environment that you are running. And we even provide a Docker file that you can build the entire pipeline as a document image, then you can even run this in Docker directly. Yeah. So yeah, so the answer is yes.
Hi, this is Jeremy. I had a question about how does it distinguish between what's important for the artifact and what is not. And then if you move to more complex workflows, like reading from a database, or reading from files, does it continue to have that good behavior?
So, hi, Jeremy. Nice to meet you. The question is, just to clarify, can you repeat the question? How does it track the complex?
Yeah, because it's cleaning out some of the code and it's keeping other pieces of the code. How do you guarantee correctness?
Yeah, so yeah, that's the underlying mechanism of a LineaPy. So basically, the underlying structure is what's called a AST, like abstract. I forgot what that fully stands for. Syntax tree, I think that's what it stands for. So when you have a code, you can actually represent it as a tree of executions, and the dependencies are listed in there, and it's part of the base Python package. And what LineaPy does is we actually leverage that base Python package to construct the internal graph, like that Abro presented earlier. And then that's how we actually know what depends on what, and and based on that graph knowledge is how we are able to actually trace back, okay, we are interested in this guy, and we are basically asking, okay, what is it linked to, and what is it the dependency, and that's how we it's basically a graph traversal, and that's how we only identify the relevant portion, and that's what's presented in the cleanup part. Does that and I have to actually clarify that it's a work in progress. It's not 100% precise, but we're pretty confident that for most use cases it's being covered. And of course, it's a work in progress, and there's a box being reported here and there, but we're making progress to address some of these edge cases. Does that answer your question? Okay. Yeah, I got it from the chat.
To add to Sang-Yoon's answer a little bit, the other thing that under the hood, LineaPy, a lot of these functions are annotated. So to give you an example, like a lot of the pandas functions have like an in-place flag, right? So if you set it to false, then it will actually return a new pandas data frame. If you set it to true, it'll mutate the current data frame under the hood, right? So in that case, that flag would be annotated, and these annotations exist in LineaPy, so that if you set the flag to true, then that variable does get mutated, and that LineaPy knows that. Whereas if you set it to false, it doesn't. So these annotations under the hood of a lot of, so like you brought up the example of like a database, right? So the database API function, if it's one of the many libraries we support, then there would be an automatic annotation. If not, you can actually provide it yourself. And that annotation lets you specify like what it mutates and what sort of, what side effects it'll have.
Yep. Thanks, Abra. And do you want to take the next one, Minter?
Yes. So, but before that, I want to add one more point to Jeremy is so when you are talking about like if you are underlining database system and your file system that your file has been changed, or your the table you read from database has been changed. In this case, LineaPy cannot guarantee you that it will produce in the same result, because LineaPy don't really record your version on the data you are sending in at this time. That if you change on if you just update the database on your side, so And so the next question is also from Josh, and he is asking, do I need a special account to run the collab? Are there other tutorials? So I actually don't know exactly answer whether you need a Google account to run Colab or not, but my belief is yes, you will need a Google account to run Colab. And so if you don't want to use your Google account, or if you don't have a Google account, we actually provide another place to run this demo notebook is actually in Binder. So if you look at our README in our GitHub page, each demo notebook or like our LineaPy 101 tutorial are all hosted. You can run them both in Colab, Google Colab, and Binder as well. Yeah, so if you run it on Binder, you probably need a little bit longer starting time, but otherwise it should work fine.
Okay, if not, I can turn it back to Arbro to close up.
Yeah, thank you. If there are no other questions, I can move on. Okay, so these are some of the many ways to connect with us, and we really hope you do. We have a community Slack channel where you can talk to other members of the community or talk to us directly. If you have any questions like or need any help, that can also be done through the community Slack channel. And then our repository LineaPy is on GitHub. So if you have a feature request or just want to check out the code or file an issue, you're free to do so. We take those very seriously, and we will take your feedback into account. For today's demo notebook, go ahead, try that on your own laptop. And then follow us on all the socials. So on Twitter, we're at LineaPy_OSS. We also have a page on LinkedIn. Okay, so we hope that you, after this amazing demo, go and try your own hand at some of these notebooks. So if you follow these steps, you actually will have a chance to win your own LineaPy Camp mug.
Yeah, and yeah, just reading out the Andy's chat message here. The slide will be shared with you shortly. And yeah, she says, feel free to click on the social icons and engage with other data experts in our community.
Cool. Thanks, guys. Bye.
All right.
Thank you, guys.
For tuning in.